So here we're going to look at equations where we're starting out with logarithms. So what we can see with these is we have these logarithms. If we have two logarithms show up, they have the same base. That's something we'll need to pay attention to. So with these, where we need to start is by isolating our logarithm term. So what we're going to do is make sure that we just have logarithm base of value equals some exponent, because then if we can get into this form, then we can switch to our exponential form where we'll have the base, we'll have the exponent, and we'll be getting some value out. We'll talk about cases where it gets kind of complicated on the other side of the equation, and in the next video, we'll kind of take it even a step further, where we will in this video look at a case where we have logarithms on both sides, but the next video will really focus on what if we have logarithms, two logarithms, and other stuff going on. So what we'll notice with this first one is kind of a simpler case of having two logarithms. But in the next video, we'll need to use some logarithm properties to help us out. So with this first example here, I want to get this logarithm term all alone on one side of the equation. So with that 20 multiplying out front, I need to get rid of that. So I'm going to divide both sides of the equation by 20. So logarithm base 4 of x equals 10 over 20, which is the same thing as 1/2. So now I have my logarithm equals a number, and we can change to exponential form. So we're going to have our value of x equals, so the value goes to one side of the equation all alone, and then we'll have our base and exponent. So that's going to be 4 to the 1/2, which is the same thing as square root of 4, which is equal to 2. So x is equal to 2. Actually, before I square that, because an important piece here is that with our exponential equations, checking the answers, checking the solutions is just kind of highly recommended. But something that will happen with those is as long as you have the correct solution, you don't need to worry about extraneous solutions, meaning they're going to work. Because our domain of the exponential function is all real numbers. We can plug anything in to our exponential functions. But as we talked about with logarithmic functions, we're restricted because the value that's put inside of the logarithm has to be larger than 0. So here we can tell our solution is going to be just fine here because we have a value that's larger than 0 going in there. But something we have to do here is you must check solutions, because we might end up with solutions in the solving process that work mathematically but don't work for this function that is a logarithm. So we have to check our solutions because we might get extra ones that don't work. So what we would do is check by plugging in 2. So we have 20 times logarithm base 4 of 2. And I want to know if that equals 10. And to plug in this logarithm base 4 of 2, I would need my change of base formula. If you wanted to plug that into a calculator, we could evaluate that without a calculator. But just to get used to our calculator, I would do 20 times and then a fraction of logarithm of 2 over logarithm of 4. And we see we get our value of 10. So that works perfectly. So x equals 2 is our solution. All right, with this one here, x is in the base, but what we do have is our setup of logarithm equals number. So what we're going to do is change to exponential form. So we'll have that value of 81 on one side of the equation equals base of x with an exponent of 4. Now what I need to do is get rid of that exponent of 4. You can think of this in two different ways. You could think of it as raising both sides to the 1/4 power. That works great. You could think of it as the fourth root of both sides. That's absolutely correct as well, in that this 81 to the 1/4 is the same thing as the fourth root of 81. Whichever way you like, it does the same exact thing. The fourth root of 81 is equal to 3. And you can type it in. In fact, it's usually a bit easier to type in those rational exponents into the calculator, putting in 81 to the 1/4 power, 1 divided by 4. And we can see our value of 3 there. That works great. So to check our solution, what I would be doing is plugging in 3 for x. So I'm taking log base 3 of 81, and I want to know if that's equal to 4. So what we could do is go to the calculator and plug in change base formula. So logarithm of 81 divided by logarithm of 3, and there's our value of 4. So that checks out. There we go. So let's look at a case where we have two logarithms. So what I want to do here is, if I have two logarithms, and what's also key here is that there isn't a value adding or subtracting outside. Now multiplying outside, we can take care of that pretty quickly. I wouldn't want to divide by 2, because then that would just make a denominator over here, since the 2 wouldn't go inside. Instead, what I want to do is to move this 2 away. I'm going to use the exponent rule, and the idea that that can come inside as an exponent over everything inside that logarithm. So I'm going to change that to logarithm base 4 of x plus 1 squared equals logarithm base 4 of 25. So now that I have this logarithm base 4 equals logarithm base 4, what happens is the fact that this logarithm base 4 piece, it kind of cancels out because it's having the same exact operation on both sides of the equation. So what this equation really comes down to is what's inside of the logarithm has to be exactly the same for this to balance. So the key being, there's nothing else adding, subtracting, multiplying, dividing on outside of these. These are logarithms of the same base, and we're saying this logarithm base 4 is exactly equal to this logarithm base 4. So what that means is whatever's inside has to be the same. So what we can do is simplify this to just being the calculation of where is x plus 1 squared exactly equal to 25. That's what we need to really solve in order to get x. So we're going to take the square root of both sides so that I just get x plus 1. We took the square root of both sides, so I'm going to have plus or minus, and then square root of 25, which is 5. And I'm going to subtract 1 from both sides. So this gives me x equals -1 plus or minus 5, which I'll go ahead and split into the two solutions. So x equals -1 plus 5, so 4, and x equals -1 minus 5, which is -6. And then what I have to do is I have to check my solutions. So I'm looking at 2 times logarithm base 4 of 4 plus 1. And I want to know, is that equal to logarithm base 4 of 25? So what we could do is go to a calculator. This would be the same thing as 2 times logarithm of 5 over logarithm of 4. And I want to see, is that equal to logarithm of 25 over logarithm of 4. So we can compare those in the calculator. So 2 times, and I'll have my fraction, logarithm of 5 over logarithm of 4. and we get that 2.32-ish. And then I want to compare that to logarithm of 25 divided by logarithm of 4, and it's the same exact answer. So that balances out, so that tells me that 4 works great for a solution. Plugging in -6, what we can see is this is going to fall apart pretty quickly, because on the left-hand side, we're going to take 2 times the logarithm of base 4 of -5, and we cannot take the logarithm of a negative number. So 0 and smaller we cannot plug in, so this is an issue. We can't do that, so that tells me x equals -6 is not actually a solution. That was an extraneous solution that we got out there. So that's why we have to check our answers. All right, one more here. So we have logarithm base 2 of all of this inside equals a value of 2. So we're all set up to change to exponential form because we have logarithm value. So we're going to, exponent, just to get our vocabulary right, because the value is inside here. So that's going to be alone on one side of the equation, equals base 2 with exponent of 2. So we end up with x squared plus 3 equals 4. And this is going to be quadratic, but it's a quadratic with only x squared. So I'm going to get x squared all alone on one side of the equation. So I'll subtract 3 from both sides. So I'll have x squared equals 1. Take the square root of both sides, so that we'll end up with x equals plus or minus 1. Now to check this out, I need to check my solutions. So we're taking logarithm base 2 of 1 squared. Let's go positive 1 squared plus 3. And is that equal to 2? So this is logarithm base 2 of 1 plus 3, which is 4. And we could do this without a calculator, because again, the logarithm is saying what exponent do we need on 2 to get 4 out? And that would be 2. So that works great. If we plug in -1, what we'll see is because we're squaring it, it ends up being okay. Because when we square it, that'll be a positive 1 plus 3, so we end up evaluating the same thing. So x can be positive 1 or -1 with that solution. So with these first cases that we're looking at, you want to isolate the logarithm so you can change to exponential form. Or what can occur is if you have logarithms on both sides of the equation, what you can end up doing is just solving by setting the inside of the logarithms equal to each other.